Presenter for this session is Mayada Abdurrahman. And Mayada is the Director of Product Management at Cisco, where she leads the Speech AI portfolio for Webex. And her work focuses on integrating the latest AI trends into collaboration tools. And Mayada joined Cisco after the company acquired Voicea, an AI startup where she headed product and technical program management. With over 15 years of experience in both software and hardware, she holds an MBA from Duke University and computer science degree from American University in Cairo. Please welcome Mayada. Thank you.
Thank you so much. All right, so we talked all about LLMs, right? And today I'm going to talk to you about speech AI and the core and the fundamental role of speech AI in large language models and generative AI applications. So speech AI is at the core of generative AI applications, especially in multimodal experiences where audio and text are leveraged to create seamless voice interactions, transform the user experiences, and enhance accessibility. So at Webex, we built homegrown speech technologies such as speech-to-text, text-to-speech, and others that have been pivotal in the adoption of generative AI applications. So one might wonder, why build in-house technologies? Like, there are so many models out there. And the reason is because when we leverage third-party APIs or genetic models, we don't achieve the level of quality that we owe to our customers. So what we do, and that brings us to the main 4 pillars of the Webex in-house technology. The first being innovation. Our goal is to accelerate the speed of innovation across our portfolio, whether it's in a contact center setting or meeting or calling setting, leveraging speech technology. Our goal is also to, from an accuracy standpoint, is to achieve state-of-the-art accuracy when, for every model we ship, as benchmarked on the latest, on the state-of-the-art models, and also make sure we achieve real-time and near real-time in terms of fast turnaround of the speech assets. We need to do all of that while also maintaining a low dollar per minute. So you heard Chetan talking about, and Annika about the different models, and the larger models can have different latencies, but also you don't need a huge model to solve every problem. And in order to be able to, at the end of the day, you're launching a product. This product needs to be profitable, so cost will continue to be a huge aspect or metric that you need to track. And that's why our goal is to continuously try to reduce our dollar per minute. And then last but not least is responsible AI. We believe that AI can provide an inclusive future for all, but because we're applying AI in our applications, we need to make sure that we mitigate any potential harm. And that's why at Cisco, we follow religiously the responsible AI framework, including privacy, security, reliability, accountability, fairness, and transparency. So today we're going to cover some of the core challenges we're trying to solve for our customers and what models we've built in order to solve those challenges. So challenge 1 is convert my speech to text. And for that, we built automatic speech recognition. So to simplify, how does automatic speech recognition work? So automatic speech recognition is the process of turning speech to text. And once we have that text, we can leverage large language models to do a lot of interesting things, such as transcriptions or summaries or action items or having a conversation with a virtual agent. So let's take an example from when someone says the word sea lion to actually seeing the word sea lion in the Webex interface. So the first step is that we take that audio and we break it into frequency components, which is a pre-processing step called feature extraction. And then the acoustic model answers the question, what does it sound like? So we take those frequency components and we map them to something called phonemes. Phonemes are basically the sounds that people make when they speak a specific language. And then the language model basically answers the question of what do humans typically say. So the language model determines what the user might have actually said from multiple words that sound exactly the same, as you can see in these 4 different alternatives, depending on context. So the language model, once those word alternatives have been created, loops through these different word alternatives, rescores them, and based on the context, can determine what is the user is actually trying to say. And then we apply something called post-processing, which is basically to decorate the transcript. And by that, I mean capitalize, add punctuation, capitalization, so that the transcript is more readable. And then you get sea lion. And we do that for every language we ship. And we have 5 different languages that we built in-house, which takes us to the second challenge. What language am I speaking? And for that, we've built language detection. So as you know, Webex customers are diverse and global. So we need to understand what language is the user speaking, because whether we are trying to provide closed captioning in the language that the meeting attendees are speaking, or we're trying to assign a virtual agent that speaks in the language of the caller, it's very important to understand automatically what the language that the customer is speaking. And for that, we've built a language detection model that basically runs in streaming, meaning in real time, or in batch, meaning after the fact. This model detects speech in 6 different languages, silence, music, background noise, and it achieves around 90 to 95% accuracy on 6 languages, which is better than Whisper, which is an OpenAI model, as measured on Webex data, and that's very important to note here. It also has a real-time factor that's pretty significant, where we are able to detect 4 hours of audio in less than 0.5 seconds. So I'm going to walk you through a very quick demo of how it performs real-time.
Selten. Also ja, unsere Kollegen können schon unsere Freunde sein, aber meistens haben wir wenig Zeit für Freunde und Familie. Und das
So you
heißt,
can
wir
see
freunden
here
sich
someone
mit
speaking
Leuten.
German and the language code is showing up.
If you've got a
as
user who
German.
has multiple phone numbers of work type, or a machine account that has multiple phone numbers.
Pues bueno, muchísimas gracias, atención y el detalle, y bueno, pues qué bueno que nos.
Du coup, il faut discuter avec elle. Mais donc, j'entends le message, ce serait bien qu'on mette ça en place. Le call de synchro sur les...
Okay, so hopefully you heard that. So just for sake of time, we showed 4 languages, but it can detect, like I said, 6 languages, silence, background noise, and others. Thank you. Okay, now let's jump to the third challenge. It didn't get my name right. Everyone wants to see their name accurate, and not just names, but proper nouns as a broader category, which means industry terminologies, people's names, product names, acronyms, jargons. We have a lot of them in every organization. So take that example, a scenario where transcription errors can cause significant drawbacks in language understanding. So Taylor and Wade confirmed that the company's financial records were SOX compliant. Clearly, that was not what was intended. So custom vocabulary basically enables us to detect out of vocabulary words and proper nouns and properly transcribe them. And as you can see here, those words were corrected in the transcript after we applied the custom dictionary. So our custom dictionary models achieve more than 93% accuracy on proper nouns and out of vocabulary words. So imagine a situation where you have a critical business meeting or a medical consultation or a legal deposition. You want to make sure that accuracy is paramount in those specific situations. And especially once you take that transcript and apply it into a language model, the downstream processing is impacted by errors in transcript as well. So this feature has been built with personalization and security in mind, meaning every organization has its own dictionary, so it's not shared across orgs. And also data is encrypted to make sure it's private and secure. Now let's jump to the fourth challenge, who spoke when? And for that, we built speaker diarization. So imagine a meeting where we're all here, we're talking through a device, and the audio is all coming into this device as one audio file. So we don't know who spoke when at the different instances. So if you look at the transcript here in this meeting where 3 people were in the same meeting room, all the utterances in the transcript are attributed to the meeting room because we don't know who that person is. So that obviously causes issues in downstream processing as well, whether it's transcription or summarization or action item assignments or others. So speaker diarization is the process of segmenting audio by speaker labels and aims to answer the question of who spoke when. So how does speaker diarization work? So the input to the model is basically a speech or an audio file. And then there is a voice activity detection model, which detects the presence or absence of speech and generates timestamps for speech activity from the given audio recording. And then there is a speaker embedding extractor, which extracts the speaker embedding vectors containing voice characteristics from the raw audio signal. And then you have a clustering module, which basically groups together the speaker embedding vectors that includes those voice characteristics. And then we have a neural diarizer, which then estimates the speaker labels. So from that one audio file, we're able to say those are 4 different speakers, and this is when each one of them have spoken. So this model right now achieves best-in-class accuracy when compared to some of the best-in-class, and is 2.5 times faster than the benchmark. So I'm going to show you a quick demo of the same meeting you've just seen, where the audio file will be broken down by the different speakers and giving
Good
them
morning,
different
everyone.
speaker labels.
We're here to evaluate whether we should consider investing in MedAI, a startup that's using AI to improve healthcare data analysis. Dr. Smith, could you start by giving us an overview of the current impact of AI in healthcare?
Absolutely. AI is revolutionizing healthcare in several ways. It's enhancing diagnostic accuracy, personalizing treatment plans, and improving operational efficiencies in hospitals.
Yeah, that's a great point, Dr. Smith. MedAI in particular.
Good morning, everyone.
I don't want to turn all from the beginning, but basically,
Good morning,
the next utterance will be the third speaker and then the fourth speaker. And that model achieved that diarized transcription by 100% accuracy. So once we have that, once the model has assigned the different speaker labels, they can show up in the UI where users can go and enter the actual names from the drop-down of the different attendees. And those are fed back to the model so that the model can detect them automatically in the future. Now let's talk about the fifth challenge today, and it's converting my text to speech. So text to speech is critical for several use cases. For example, in customer support on IVR, by providing voice responses to customer queries, and that basically decreases the reliance on human agents, especially for routine calls. In virtual assistants and AI agents, we've all seen different demos for that, and that allows AI agents to speak in a human dialogue almost to customers, to respond to queries, provide information, which makes it more interactive and accessible. And then in audio-to-audio translations, which breaks down language barriers in real-time meetings and conferences, and also enhances accessibility by providing audio information rather than text information for people who prefer or need that. So we built an end-to-end text-to-speech model architecture, which is the latest architecture in text-to-speech, to generate high-quality speech with variability in rhythm and pitch. So our model runs in streaming mode and has minimal distortion or artifacts. It supports the different telephony codecs, and wideband and narrowband. Phase 1, we have English with 4 different dialects, and then phase 2 will support more languages. We support SSML, which basically allows you with no code basically to adjust volume, pitch, rate, say as, which basically allows to customize how the text-to-speech will pronounce different dates to different numbers, emphasis to increase and decrease volume and rate, and insert silences. And we leverage a lot of different metrics in the industry to make sure that those voices are natural and at least as least robotic as possible. So let's talk about metrics and benchmarking. So basically, the models that you've seen, we've achieved more than 90% accuracy on Webex data as measured on the best-in-class, again, as measured on Webex data, because that's the data we care about for that specific experience. And to put things in perspective, human accuracy has been measured on some of the public data sets called Home, and human accuracy has been measured at 93%. So with that model, we're also 6 times faster than Whisper Large on streaming and 10 times faster on offline. Same thing for all the different languages that we ship: Spanish, French, German, Italian, and English. And then for latency, which we talked about earlier, why is this important? Streaming transcription is important in use cases where you need to transcribe audio in milliseconds, but it's expensive and compute heavy. But batch transcription is historically cheaper, but slow. So we're targeting to build batch in near real time. So that would achieve almost 60% reduction in cost and compute. And it can be leveraged in different use cases where you don't really need real time in milliseconds, but you need within a meeting experience or within a call, such as, for example, in-meeting summary or auto responses from a virtual agent. So we've talked through a lot of different challenges that we're able to solve with some of the speech AI models. And this is just a few features that we have. We're building the speech AI portfolio, which encompasses a comprehensive suite of speech AI features. And like we mentioned in the beginning, all of these models are leveraged in combination with LLMs to provide really transformative user experiences to our customers.
Okay, let's get caught up.
Introducing built-for-purpose AI tools for hybrid work. Get caught up in previous meetings.
Oh, looks like I need to check in with Felix.
Interact with an assistant in real time to get better context. AI-powered workflows bring unparalleled flexibility, accountability, and balance to our busy lives.
Great. The projects are in good hands.
And what about voice?
Or if
I didn't get a confirmation.
Okay, give me a few moments to look for your case and I will put you on a brief hold.
Hello?
We've all had this happen. The call drops and you've got to start all over. The power of the Webex platform brings generative AI to voice calls.
I see you're on a call regarding a booking issue. I believe you're trying to book a flight from LA to Portland.
AI summaries arm agents with all the details so customers never have to repeat themselves.
And you will receive a confirmation shortly.
After the call, customers receive a full summary to their preferred channel of communication. Reimagining work with Webex AI.
Hopefully that gave you an idea about how it all comes together. And with that, thank you so much. If you have any questions, appreciate it. Thank you.